So question 5 goes as follows. It says the sketch below shows two functions f and g. The graphs of f, which is a hyperbolic function, and g is a straight line function respectively. Points a and b lie on the graph g. There they are, b, and there's a. Right? The two graphs intersect at points c and d. So they intersect at C and D, right? Line BE is drawn parallel to the y-axis with E on F. So those two lines BE is and the y-axis are parallel to each other, and they form 90 degrees. BE forms 90 degrees with the x-axis. It's very important that we make notes of these critical information, right? So let's go to the first question. It says, it reads as follows. So basically they want us to find A and Q, right? So in other words, we need to find the equation of the function, the straight line function g. So we are provided with 2 points on the line B and A, so it's possible then to find the gradient A. Therefore A should be y capital A minus y capital B all over y x capital A divided by x capital B. So let's substitute the coordinates. Minus 4 minus 4, negative 4 minus 4 divided by negative 1 minus 3. So that gives us 8 over 4, and 8 divided by 4 is positive 2. So we already have the gradient A, so all that we need now is the y-intercept q. So therefore g of x is equals to 2x plus q, right? But we can find q by substituting one of the 2 points into the function. So let's substitute b, 1 and negative 1 and I think let's substitute b into g of x. Okay, wait, b's coordinates are wrong. It's supposed to be, let me just fix that. B's coordinates are supposed to be, let's erase that. B's coordinates are supposed to be 3 and 4, right? So let me write 3 and 4. So g of 3 should give you 4, and 4 is equals to, all that we're doing is we're substituting these coordinates into the function. 2 times 3 plus q. So now the only thing left is to make q the subject of the formula, or to solve for q, which is 4 is equals to 6 plus q. So this implies that q should be equals to negative 2. And quite clearly these points, so therefore A should be positive 2 and q should be negative 2, and that is exactly what we have in 5.1. right, so let's go to 5.2. 5.2 reads as follows. It says, determine the values of x for which the two functions intercept. F of x is equals to g of x. So we equate the two functions as is and solve for x. So let's do that. To find the x-intercepts, the points for which the x values intercept, the points intercept for x values, we need to equate. So f of x is equals to g of x, right? And we know that g of x is 2x minus 2. It's a straight line function, and f of x is 1 over x minus 1. So just a matter of substituting or solving for x rather. So what we can do here is we can multiply the left hand side and the right hand side by x to eliminate x in the denominator on the left hand side. So we are left with, let's start with the left hand side, 1 minus x is equals to 2x squared. Remember, all that I did was minus 2x. I multiplied left hand side and right hand side by x. So write this in standard quadratic form, right, so that we can find the solutions. So 2x squared minus x minus 1 is equals to 0. So the factors are as follows: 2x x should be equals to 0. We can add negative 1 there, positive 1 there. You can verify that. So therefore x should be equals to negative half, or x should be equals to positive 1. So those functions intersect when x is equals to negative half or x is equals to positive 1. Right, let's have a look at 5.3. So we want values of x for which g of x is greater than or equals to f of x. So g of x has to be above. On the plot, g of x has to be above f of x. So let's look at those regions, and by inspection we can already see g is greater than f in this region, greater than or equals to. G and f are equals to each other at D, but then g is greater than f in this blue region. And we know what the x coordinate of D is, because D is the intersect of f and g. So x has to be greater than or equals to positive 1. Remember, g has to be greater than or equals to. So in this region, for any value for which x is greater than or equals to 1, is g greater than f. And you can see it there. G is greater than f. The second region is there. I'm just showing you guys that small region. You can see that g is above f when x is equals to or greater than c, right? But then f stops being greater than, g stops being greater than f at the y-intercept of g, because that is an asymptote to the hyperbola. So x lies between, is greater than negative half, greater than or equals to negative half, and x has to be smaller than 0, right? Only in that region is f above, is g above f, right? So that's quite, so x has to be greater than or equals to negative half or smaller than 0, and x has to be greater than or equals to 1. So moving along, now they want us to find the length of BE. So let me just color in BE. They want us to find the length that I'm coloring now with green, that length, right? So because that line is a parallel line to the y-axis, it means that E shares an x coordinate with B. So E's x coordinate is 3 for the very reason that BE is parallel to the y-axis. And then we can find the y coordinate of E because point E falls on the hyperbola, and we can substitute the x coordinate in the function to find the y coordinate. So let's do that, right? So f of 3 should be equals to 1 over 3 minus 1. So a third minus a whole is negative 2/3. So now we know what the y coordinate is, right? It's negative 2/3. You know what, let me just not write it here. Okay, so there we have it. That's the y coordinate of E. So now we know the distance between this distance here from the x-axis. Let me just use black. Okay, this distance here is 4 units high, right? And then the distance beneath that is 2/3. So just adding those two distances gives us the length of BE. So this implies that BE should be equals to 4 plus 2/3, which is 4 and 2/3. 4 and 2/3. Very straightforward. And finally, the last question goes as follows. So I want us to write down an equation of h if h of x is equals to f of x plus 3. So f of x is just being translated 3 units, right? So let's just substitute. It's important is to rewrite that equation, or that new function. H of x is equals to f of x plus 3, and then substituting f of x. So h of x is equals to 1 over x minus 1 plus 3. So 1 minus 3 is 2, so it's 1 over x plus 2. Thanks guys for watching. Please do subscribe to my channel. Thank you.